Then we have stretch and compressions. So a vertical stretch or compression means you're multiplying the entire original function by some constant. And depending on the value of that constant will depend on whether or not you're stretching or compressing. So if that a, that constant, is greater than 1, then that means it stretches vertically by a factor of a. In other words, if you're multiplying everything by 3, then all the y values are going to be multiplied by 3. So it's going to stretch it. If a is between 0 and 1, then it compresses, and it's still vertically, by a factor of a. So all the y values, like if a was 1/2, all the y values get cut in half. So it will compress. Now, a could be negative, but then we're just going back to the reflections. So if a is less than 0, then we have both a stretch or compression with a reflection over the x-axis. So you just combine them both. So let's do a couple examples. Here are 2 pictures of f of x, and we want to graph 2 different transformations. We want to do one with 2 times f of x, and remember that just means we're multiplying 2 times all of the y values. Let's do that one first. So again, let's look at all the y values that we know. I'm going to kind of indicate those points. And we're going to take all of the y values and multiply them by 2. So the x's will not change. So the first point on the left, our y value is -2. Multiply that 2, and we end up going down to -4. Second point, our y value is 3. Multiply that by 2, and we get a y value up here at 6. Third point, our y value is 1. Multiply it by 2, and we get a 2. Fourth point, our y value is 2. Multiply it by 2, we get up here at 4. Our last point, our y value is -4. Multiply it by 2, and we get down here to -8. So if we connect all of these points, you can see how we've taken the original equation or the original graph and stretched it by a factor of 2. With the second equation, second graph, we're going to multiply all of our y values by 1/2. So that means we're cutting the y values in half. So our first point here, where our y value is -2, we're going to cut it in half to a -1. Second y value up here at 3, we're going to cut it in half and be at 1/2. Third y value at 1, cut it in half, and we're going to get a 1/2. Our next y value is at 2, cut it in half, we'll be down here at 1. And our last value at -4, cut it in half, and we'll be at -2. Combine these points, and we have compressed the graph by a factor of 1/2. With a horizontal stretch or compression, it's the inside x variable that is being multiplied by a constant. And again, the value of that constant will tell us if it stretches or compresses. But once again, that inside change doesn't work the way we think it would. So if b is larger than 1, we compress by a factor of its reciprocal, 1/b. If b is between 0 and 1, let's say 1/2 or 2/3, then we stretch horizontally by a factor of 1/b. Just remember, if b, let's say, is 1/2, then 1/b is the reciprocal 2/1. So that's why it's stretching by a factor of the reciprocal. And again, if b is also negative, then we have either a stretch or compression with the reflection over the y-axis. So once again, f of x is given, but this time the transformations are affecting the input value. So if we do the first one, where we're multiplying the input value by 2, the y's are going to stay, but the x's, they're going to compress because we've got a number larger than 1. So this guy will compress by a factor of 1/2. So over here, our x value is 6. So half of 6, or -6, is going to be -3. With our next point, our y value is -3. Half of that is 1.5. Our next point, our x value, we're going to say it's a 2. I know it didn't land right on it, but half of that gives us a 1. This value for x is a 3. Half of that is 1.5. And this last x value is 6. Half of that gives us a 3. So if we connect those points, we have the same original graph where all the y values are the same. Notice it doesn't change the domain, the range, but it's now compressed. Let's do the same with f of 1/2 of x, which means it will stretch by a factor of 2. Again, just the x values, not the y's. So our first x value here on the left, -6, multiply it by 2, that's actually going to get us way out here at like a -12. Our next x value is -3, so he's going to stretch to a -6. This y value of 2 is going to stretch to a 4. Y value of 3 will stretch to a 6. And our y value of 6 will stretch way out here somewhere off our graph to a 12. If we were to connect these points, we have our stretched version by a factor of 2.